Hello, my name is Brenton Basinger. I'm a student in the Master of Science in Business Analytics and Information Systems program at the University of South Florida. In this video, I'd like to share with you my independent study project. Let's get started.
Let me start by giving you a little background. I work for a beverage company. Yep, that one. And about a year ago, we converted 20 unused offices into huddle rooms. The idea of a huddle room is that if you have a small group of people that need to meet privately, a few people who want to join a conference call with a speakerphone, or all the regular conference rooms are booked, you can use one of these huddle rooms. They're available on a first come, first served basis, meaning basically you can't reserve a huddle room like you can a normal conference room. Initially, I was thinking this is going to be a great idea. Now, if I need to meet with my team, we can just go into one of these huddle rooms and have a quick meeting. There was one slight problem with this whole huddle room idea. What started to happen was that each time we would go to try to find an open huddle room, we would end up gathering the team and walking around the entire building, only to find that all of the huddle rooms were occupied.
Walking around the entire building to see if a huddle room is available seems like a less than optimal solution. If only we knew someone who has been spending their nights and weekends for the past 2 years learning about business analytics and information systems, I bet they would be able to create a solution using IoT to solve this problem.
Yeah. So a couple years ago, I took classes at the University of Washington to earn my certificate in Python programming. It was during one of those courses where I first saw one of these little things. It's called an ESP8266. It has a little Wi-Fi microchip with a full TCP/IP stack and a microcontroller that allow you to install MicroPython, Mongoose OS, Arduino, or several other SDKs. It sells on Amazon for about $5, but you can get it even cheaper if you order them directly from China. So to tell if a huddle room is occupied, I'm going to need some motion sensors. Amazon sells these little guys called SR501 PIR motion sensors for about $1.75 each. Again, even cheaper if I order them directly. I figured since I was putting these in huddle rooms, it might be helpful for people to know the temperature of the room. So again, Amazon to the rescue. I ordered these DHT22 temperature and humidity sensors for about $5 each. I use 6 DuPont wires to connect the pins, power, and ground to both of the sensors. For an enclosure, I found a company in Avon Park, Florida called Semco. They manufacture injection molded enclosures, so I got a few of these for about $5 each. I drilled out a couple holes for the sensors and USB power cable, used some super glue to hold the sensors in place, then put in the 4 screws to secure the back of the enclosure. Plug in a USB cord for power, and there you have it. An IoT huddle room monitor for under $20. Great question. So, instead of walking around the entire building to try to find an open huddle room, now you can just go to a website and see in near real time which huddle rooms are available and also the current temperature. Pretty cool, right? So it works like this. Each time the little PIR motion sensor gets activated, it is connected to GPIO pin 16 on the ESP8266. The Mongoose OS firmware running on the board tells it anytime GPIO pin 16 gets tripped, I want you to send a message. To send this message, I use a message protocol called MQTT. It's a lightweight M2M or machine-to-machine connectivity protocol for the Internet of Things. It uses a publish and subscribe message transport system. That means it allows me to send messages to the cloud where it is listening for messages coming in about that topic. Yeah, kind of confusing. Think of it like this. On the cloud, I'm subscribed to a topic, let's call it green, go Bulls. Imagine that there are a lot of messages coming into the IoT hub. However, the only ones I care about are messages being sent with a topic of green. So just ignore all the other ones. Make sense? So, if the motion sensor is not activated in a long time, I would still like to know the temperature in the huddle rooms. For this, I send another MQTT message with the temperature every 2 minutes, regardless if the motion sensor has been activated. If the motion sensor does get activated, I also send a current temperature reading along with the motion activation message. When I say I'm sending these messages to the cloud, what I'm really doing is sending them to a server that's owned by Amazon Web Services. They have a product called IoT Core, which I can configure to listen for these MQTT messages that I'm sending to it. All right, now I have all these messages going to AWS IoT Core, but I need to save them somewhere. For this, I had originally planned to just throw them into a S3 bucket. S3 is another one of the AWS services. S3 stands for Simple Storage Service, in case you were wondering. I can distinctly remember the utter joy I felt the day I was finally able to send a message from my little IoT sensor and it arrived in my S3 bucket. That joy lasted about 5 minutes until I realized that each time a new message was sent, it just kept overwriting my previous message. So, about 2 days and a box of Kleenex later, I figured out you need to use this thing called Amazon Kinesis Firehose in order to append all of these incoming MQTT messages into one JSON file and then store that in an S3 bucket. And that day, joy returned to my life. Okay, so now we have all of these messages from huddle rooms across the fruited plain coming into this S3 bucket. This is really not going to help me in making a near real-time dashboard. I needed to figure out how to pop the incoming motion and temperature readings out of this JSON file so I can update the dashboard with it. For this, I used AWS Lambda, really just a fancy word for yet another AWS service that provides serverless computing. It's just inline code that runs when something happens. In this case, each time a new message gets added to the S3 bucket, my Lambda code runs and it takes that sensor information and updates a JavaScript file in another S3 bucket. That's a total of 2 S3 buckets for anyone playing at home. So now, to create this cutting-edge, state-of-the-art, near real-time huddle room monitor dashboard, wait for it, I just created an index HTML file and put that in my S3 bucket to create a static web page. I also put a jQuery JavaScript file that tells my index.html file to read from that JavaScript file that's being updated by the Lambda function. Yeah, so at this point, I assume most of you are like, demo, demo, demo. Or more likely, you stopped watching several minutes ago. But still, let's see this IoT huddle room monitor thing in action. All right, since you're still here, you must actually want to see a demo. Once you have the motion sensor and temp sensor all connected to your ESP8266, you need to load some firmware on it to make this whole thing work. As I mentioned earlier, I used Mongoose OS to build my firmware. I just went to their site here and downloaded and installed it on my local machine. Once you launch the software, you can go to the IP address 127.0.0.1, port 1992. This is easy to remember because that's when Columbus sailed the ocean blue. This allows you to view the session in your browser, making it a lot easier to work with. Next, I wrote, really modified, thanks Stack Overflow, the JavaScript file that I needed to build my firmware that would be installed on each of these ESP8266 boards. First, I establish what I want to happen when one of those pins is activated. In this case, I want the ESP8266 to send an MQTT message to the topic get/payload on AWS. and also subscribe to the topic Send Payload. What this will do is allow me to have two-way communication with the board should I ever need to update anything remotely in the future. Next, I name my pins, then let it know what I'm expecting it to do when one of them is activated. Here I added some error handling just in case it can't connect, so it tries again a couple seconds later. I added this counter to keep track of the last time the motion sensor was activated. I need to know this so I know when to turn a huddle room from red back to yellow if motion has not been detected in 30 seconds. Then to turn it from yellow back to green if no motion has been detected for 2 minutes or more. Well, alright, now we need to turn this into some firmware. Start by using cd to get to the directory where you have the init.js file saved. Here, we tell it what platform or board, in our case ESP8266, you want to build the firmware for. Next, we use the MOS flash command to load the firmware onto the board. Next, we tell it to connect this device to AWS. Side note, one of the cool things about this Mongoose OS thing is that it allows you to use the AWS CLI or command line interface where you load your private AWS keys before starting to build firmware. That way, when you go to connect to AWS, these keys are built right into your firmware. So AWS knows it's cool for this device to connect. Here, we're just telling it which region of AWS our IoT core is located in, so it knows where to send the messages. Okay, now you can see here on the right that it's communicating with AWS. As I realized when I tried to unhook the USB to move the huddle room monitor to another room, there's one more command we need to run. This command gives the ESP8266 the SSID and Wi-Fi password it needs to get on the internet and send this sensor telemetry. Yes, I blurted out so you guys can't hijack my Wi-Fi. And there we go. Now if I move my hand in front of this motion sensor, you can see that it is sending the MQTT message to AWS. All right, this is the screen you get to when you log into AWS. It's their management console. Up here are the recent services that you've used, so they kind of update up here along the top. As I mentioned, the S3 bucket is where the files end up. IoT Core, as I spoke to previously, is where my MQTT messages are sent, and then my Lambda function takes those incoming messages and takes them out of here, puts them in another S3 bucket, and then displays them on a website. So I guess I can walk you. Let me go back here. If I go to IoT Core and I go over here to test, you can actually test this where I go to get topic, or no, sorry, excuse me, my topic / get payload and subscribe. Now I'm going to pause this so I can run over and activate one of the sensors. Okay, now since I activated one of the sensors, you can see that this is the telemetry that's being sent. It comes through and says, hey, I just got activated. The motion is true. The humidity level, the current temperature, that's in Celsius. We later convert that to Fahrenheit. The huddle room and the huddle room ID. So as you can see, when it gets activated, it sends several messages, and then it will start sending falses as soon as it was no longer activated. So that's how the messages get there. Once they're to IoT Core, we go to S3, and this bucket here is where I put the MQTT messages. Once they get there, my Lambda function kicks in. And here's the real-time Lambda function. So anytime something's added to AWS that goes to the S3 bucket, the real-time Lambda pops that off and puts it in another S3 bucket. So here's the code for that. Again, if you go on Stack Overflow, you can find skeletons that you could use to just modify. It shows my source bucket, my destination bucket, and my source object, my data.json file. Here's the code. It's pretty straightforward. It's just given the room ID, the status of the motion sensor, and the final status. So that's the Lambda code. And what happens now is if I go here and I go back to S3, I can show you this fweb folder. And here is where you just put this index.html file. And what that does is it creates a website, essentially. It's just a standard static website. And then I'm using, I've got my little legend JPEG file that provides that little legend that goes on the bottom of the dashboard. Date time lets it know the current date and time. And the jQuery file, we can take a quick look at that. Download and open that for you. There's the jQuery file, straightforward as well. That just causes it to update the JSON file so that when it's like an API that the index.html refreshes. That's why you kind of see the dashboard flash every about 5 seconds. So that's about it here. There's the Kinesis fire hose that I mentioned that kind of takes all of those incoming MQTT messages that if you had this deployed in real world and had thousands of sensors, the Kinesis fire hose allows it to collect all that data and orderly manner, put it in my S3 bucket. So if we go to S3 and go to the index.html file, I can show you that real quick here. If we go here, click on the index.html file. So here is the completed prototype dashboard. As you can see, I've configured 4 huddle rooms. Currently, all of them are green. It displays the current temperature of each of the huddle rooms and also gives you the time stamp or the date and timestamp where the last motion was received, and then a little legend saying that if motion has been detected in the last 30 seconds, the color will be red instead of green here. If motion has not been detected in the last 30 seconds, up to 2 minutes, the room will be yellow. So 30 seconds to 2 minutes, the room will be yellow, showing you, people might have just finished a meeting and left. It might be available momentarily. And if it's green, that means no motion has been detected in that room for the last 2 minutes. So I'm going to go ahead and pause this, and I'm going to run over and activate these motion sensors so you can see what happens when they're activated. All right, now as you can see here, Huddle Room 1 was just most recently activated, so that one's red. Huddle Rooms 2 and 3, it's been, let me see, it's been about a minute and a half since those 2 were activated. So both of them are yellow, and room 4 is back to green, and now you can see room 3 just turned back to green. Here momentarily, 2 will turn back to green, and that's kind of the way the process works. So I hope you enjoyed. Thanks for watching. Bye.
Goodbye.